Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future today. Imagine an AI agent standing in front of a puzzle. One move looks good now, but 5 moves later, everything collapses. That's the core problem this paper tackles. Today's story is about a paper called Agentic Lookahead in Interactive Environments by Yangbin Yu and Mingyu Yang with collaborators from Tencent Hunyuan. This is a story about teaching AI agents how to think ahead without hallucinating the future. Large language model agents are surprisingly good talkers, but surprisingly bad planners. In interactive environments like 2048 or Sokoban, one bad assumption compounds, then compounds again until the agent confidently walks into failure. The paper calls this simulation drift. The agent imagines futures that look logical but don't match how the real environment behaves. More thinking doesn't help, it actually makes things worse. So the authors ask a bold question: what if we don't let the model imagine the future? What if we show it the real future and then teach it the pattern of good look ahead? That's ProAct, a two-stage framework that internalizes foresight without expensive search at inference time. Stage 1 teaches how to think ahead. Stage 2 teaches how valuable those thoughts are. Stage 1 is called GLAD. Here's the trick. Instead of letting the model hallucinate futures, the environment itself becomes the oracle. They run Monte-Carlo tree search in the real environment. They explore good paths, bad paths, dead ends. Then they compress those huge search trees into short, human-like reasoning chains, not raw search logs. Clean, causal, natural language thoughts. If I go left, I score now but block a future merge. If I go up, I create space but risk instability. The model learns foresight, not just answers. Stage 2 fixes another hidden problem. Reinforcement learning needs value estimates, but LLMs are slow and noisy, which makes value learning unstable. So the authors do something clever. They don't train a neural critic at all. Instead, they run thousands of cheap environment rollouts using a random policy. This becomes the Monte Carlo critic. It's fast, low variance, grounded in reality, and it plugs directly into PPO or GRPO. Then comes the test. They train a 4B parameter model on two very different worlds: 2048, long, stochastic, unforgiving; Sokoban, deterministic, sparse rewards. The result? GLAD alone crushes open source baselines. GLAD plus MC-Critic rivals closed source models. Even more impressive, the agent generalizes to unseen boards, rules, and symbols. This isn't memorization, it's learned foresight. The paper also gives a practical recipe. Dense rewards, use more Monte Carlo rollouts. Sparse rewards, too many rollouts actually hurt. And here's the big pitfall: if you don't ground reasoning in the environment, long chains of thought become long chains of mistakes. ProAct shows something important. The future of agent reasoning isn't longer thoughts, it's truer thoughts, grounded, compressed, and learned from reality itself. And this raises a bigger question. If agents can internalize look ahead, what else can they internalize next? If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.